Welcome friends, in this video I'm going to take you on an exploration of a 3D coordinate system. So the first concept is this one. I'm going to zoom out on this a little bit. We have three coordinate axes, the way you see them right here. That axis right there, where I'm kind of focusing my camera, that's the x-axis. That other axis in that position is called the y-axis, and that vertical axis is called the z-axis. This point right here where they meet, let this camera zoom in a little bit here. Where they all meet, the three mutually perpendicular axes, that is called the origin. And the coordinates of that point where they all meet are 0, 0, 0. The x-coordinate is 0, the y-coordinate is 0, and the z-coordinate is 0 in that place. When I say mutually perpendicular, notice that if you look carefully at all of the angles, those are all 90-degree angles. They're all perpendicular. So space is taken to be this kind of rigid meeting of these three mutually perpendicular axes, and that's the origin. This axis that I'm tracing, that is the x-axis. It goes this way, for example, up to 12 in my case. What I'm tracing in this direction, look carefully, that's the y-axis. In my case, it goes up to a value of 8. And then lastly, the axis that tells you how high you are, or below, for example, that I'm tracing right now, that is the z-axis. And in my case, I marked that up to a value of 8, as you see. Let's talk about constant x, y, and z values. Take a look at what I mean by that. So you see that there is an x value of 1. So when we say, for example, a constant value of x equals 1, I want you to keep a careful eye on that dashed line. Which dashed line? I'm going to emphasize this. Take a look. Otherwise, it won't be the clearest thing in the world. This dashed line that I'm kind of going to mark with this thing right here. Take a look. That axis that I just put there, that represents a constant x value of 1. You see where this here is meeting it right there? That's at x equals 1. And as you observe there, right, the y values are the ones that you're seeing change in that position. Look, 1, 2, 3, 4, 5, 6, 7, 8. See that? I'm going to leave that there for a second and give you a different perspective on it. Take a look. You see? That's an x value of 1 along that entire little piece of folded paper that I put there. X is always equal to 1. Let's continue. Let's do this one more time and a different value of x, just to emphasize the point. Say I'm going to choose 6 right here. And when I do that, that's an x value of 6 that's been fixed. And clearly the values of y are allowed to change along a constant value of x. So again, right there, that is a constant value of x has been set at 6. And then I move this way and the values of y change along a constant value of x, up to say 8 or 9 in my case. Let me zoom out so you can see the whole configuration better. Let's repeat this in the other direction, for example. Take a look here. I'm going to do it this way. I'm going to fix this to represent a constant value of y. So look right here. You see this? That there is y equals 3. That's along the y-axis. I'm going to put this line right here. And take a look. I'm going to zoom out a little bit. And you see along this entire rolled up piece of paper, the value of y is set equal to 3. But the values of x are allowed to change from 1 to 11. The ones that you can see at least. Up to 11, you see? So as I travel along that line, the value of y is constant. The value of x changes up to 11. Let's repeat this for the vertical dimension. Take a look. I'm going to do it a little bit differently. Let me adjust the camera so I can get a better angle here. I'm going to take this vertical piece right here. And look. I'm going to zoom in the right way. And I want you to first of all observe that this height that it represents is equal to 6. You see? It's equal to 6. I'm going to zoom in on that. It's equal to 6. And when we say a constant value of z, I'm going to move this way. It's going to be a bit tricky, but you'll get the picture. Take a look. You see I'm moving, and the value of z during this entire process is equal to 6. You see that? It doesn't change. The value of z is a fixed value of 6, say up to here. But the value of y clearly is allowed to change during this stage. So in other words, it's as if we did this. Take a look. I'm going to put this right here. You see? Zoom out a little bit. That's a constant value of z equals 6. Let me just write this so it looks a little better. And the values of y along a constant value of z are clearly allowed to change from, say, 0 up to 8 or 9 even in this case. If I move it to here, that's a constant value of z equals 4. And as I do that, I can observe that the values of y are clearly allowed to change up to 9. Let's do this in the other plane. This is what I mean. Take a look. I'm going to do this one more time. I'm going to fix this right here. I like doing math this way. It's much more interesting than anything else. I don't like writing math on pieces of paper. It's boring. Take a look here. So here I have a value of 6. You see that? For the value of the z coordinate. You can even count up the number of grids. 1, 2, 3, 4, 5, 6. You see? You count them carefully. And now let me zoom out so you can see that that represents, as you see, a constant value of z equals 6, but as I travel along that line, you see that the values of x clearly are allowed to change up to 12. And if I do this in a different position, let me do that next. So for example, over here. So in that position, if you think about this, that would be a constant z value of 2. And as I travel along that constant z value of 2, the x values are clearly allowed to change up to 11 in this case, you see? So these are some of the major concepts related to understanding that you can take three mutually perpendicular axes, you can put them together, you can number them, you can assign names to them like x, y, and z. And then from there, this has very specific consequences of the kind that I have shown you here. This is just scratching the surface. As you can imagine, there's a lot more that you can do in three-dimensional space because after all, we live in three-dimensional space, including, and of course, time as another dimension on top of it. But I'm going to leave it here. Thank you so much for watching. Please leave a like, and I'll see you in another physical math example.